let's continue on. Letter G. There's lots going on in these ones, but they're not really any different. But let's keep doing this. Oh, I noticed right here I'm missing a bracket. So there needs to be a bracket. Well, I'm kind of missing them here though too. X and then 2. I don't like that. I don't know if I'm missing them other places. So maybe I'll change that later. Yours might have those brackets in it. I don't know. So let's take a look at this one. We got to get the logs together. So this is a log base 4. Finally, not a log base e. Everything was log base e in the other ones, it seemed. So I've got a 12 minus x and an x. Oh, it's not timesing. It's a subtraction. It's a subtraction, so we need to divide. So we'll go a 12 minus x divided by an x plus 2. Okay, that's very, very interesting. And on this side, okay, we do multiply them because they are being added. So x times 2, which is just a 2x. So now I can go 4 to the power of that and 4 to the power of that, which will cancel those. So I have a 12 minus x over x plus 2 is equal to 2x. Okay, so we can multiply this side by x plus 2 and multiply this side by x plus 2. So I have a 12 minus x is equal to, what is this? 2x squared plus 4x. Now I'm going to keep the x squared there, so I'll move over the 12 by subtracting it and move over the x by adding it. So then I'm left with 0 on that side. Now I got a 2x squared, that's alone, so there's that. How about my x's? So 4x plus another x is 5 of them. And then just a number, constant, which is just 12. So I have to factor this now. So 2x and 1x, hopefully you remember how to factor. I need a 12 here. Okay, so this I honestly don't know what I'm doing here. I'm just guessing. So that's going to be an 8. 8 minus 3 is 5. Okay, so that worked out quite nicely. And this is multiplied to negative 12, and this is multiplied to 2. Okay, perfect. So, I don't want to get myself stuck here, but we're going to try writing this. I get 0 equals 2x minus 3 and x plus 4. Therefore, I've got 2x minus 3 equals 0, or an x plus 4 is equal to 0. So I'll plus 3 to the other side, which is 2x equals 3, and then divide both sides by 2. So, I mean, you could write this plus 3, divide by 2, divide by 2. I think I wrote that in the notes in case you wanted to. Nope, I did not. I'm looking at them now. But this part should be very, very simple. Same with this, minus 4, so you're just going to get a negative 4. Now, this is a negative 4, this is a 1.5. Negative 4, do you think that would be rejected? So like if you put a negative 4 into here, you're going to get 12 plus 4, the double negatives is a plus, and you're going to get 16, so that works. But the negative 4 in here would cause it to fail. Negative 4 plus 2 is negative 2, so that's automatically rejected. And in fact, a negative 4 here is negative 4. So that gets me a negative number, so I'll reject it. If I get 1.5, 1.5 in there is good. 1.5 plus 2 is 3.5. 12 minus 1.5 is, what, 10.5? So either way, those are all positive numbers, so those are good. Okay. So that was a long question. Let's try another one here. We are adding these, so we'll multiply. It's log base 5. So x times x minus 3. And this is a log base 5 of 2 minus x squared. Okay. So, x times x, I'll go 5 to the power of, and 5 to the power of. So this is going to be a x squared minus 3x. And on this side, I'm going to just be left with a 2 minus x squared. Okay, so I'll move the more negative x squared. I'll add that over, which means I'll move that as well. So I'll add an x squared, and I'll minus a 2. So I'm left with x squared plus x squared, which is 2x squared. I've got a negative 3x and a negative 2, or a minus 2. Now, is that factorable? Let's see. So 2x and 1x, or just an x, 2x and x. and then 2 and 1 make that negative, and I get a negative 4 plus 1 is negative 3. So that's good. Yeah, I think that works. So I am left with here 2x plus 1 there, and an x minus 2 is equal to 0. So I've got a 2x plus 1 can be 0, or an x minus 2 can be 0. So I'll minus the 1 over, it becomes a negative 1. And then I'll divide by 2, so it's a negative 1 over 2, which you could also write as negative 0.5, just for checking. Right? You want to check. Sometimes it's easier to check it with a decimal. And then if I add the 2 over, I get a 2. Okay, so is there any failures? So I'll take the 2. 2 goes in there, you get a 2. That works. 2 goes into here. 2 minus 3 is negative 1. Can't have a negative. Let's reject that one. Negative 0.5. Look, if you put that into here, it becomes a negative 0.5. So it fails there. If you put it into here, negative 0.5 and negative 3 is negative 3.5. It fails twice. Okay, so that's rejected as well. So therefore, there's actually no solution. There's no answer to that one. Okay, so that's good. Now, I want to try, I'll just do one of the other ones to see where we're headed. Now, this one, there's not logs on both sides. So the hint for this is you want to isolate the logs onto one side. So you want to get the log alone. That's our goal. So first thing first, we'll minus this 3. And these aren't too bad, actually. So get the log alone and on one side. So I get log base 2 of x plus 3, and then 7 minus 3 is 4. And then it's the same thing. 2 to the power of, 2 to the power of. So that's gone. The only problem is it's not gone on the other side. 2 to the power of actually ends up being 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then you can just minus the 3, minus the 3. So you get x is equal to 13. And then you could check that, put 13 back into here. 13 plus 3 is 16. So that won't be rejected, doesn't fail there. So that's what that question is like. And that's what the B, C, D, B, C, and then the next A, B are going to be like as well, where there's no longer logs on both sides. There's just these constant numbers that are going to need some work there. So I will stop the video here, and we will do another video for these other questions right after this.